Hi, welcome back. In this session, we're going to have a look at cluster API. We're going to look at the what and the why. So why is cluster API important? Why would you use cluster API? And then how it actually works and the various components that make up cluster API. So first, let's take a look at how we spun Kubernetes clusters up in the beginning. And there was really only one way to do that, and it was called CubeUp. So if you could spin up a cluster in any way you wanted to, as long as that way was using CubeUp. So eventually, as things got more complicated and we started to use additional services and run different types of workloads in our cluster and needed to scale the clusters independently of infrastructure, we realized that we needed a better methodology for kind of creating and bootstrapping this cluster. Now there are over 82 distributions and installers for Kubernetes, so things got out of control, fairly quickly. So that's why it became important to have some sort of standardization for bootstrapping a cluster, creating a cluster, even provisioning infrastructure to support the cluster, and then automating that entire process. So that's where cluster API comes into the mix. So we're looking at how do we build a cluster and what makes up a cluster. So we have infrastructure that comprises kind of the basis of our cluster. So virtual machines or bare metal servers, firewall rules, networking, load balancer, things like that. Then we have the actual components of Kubernetes, which we went over at length in our last session on the Kubernetes overview. So our API server, our etcd store, how do we create all these resources and ensure that they're connected to each other. And then also we have things that we want to layer on top of our cluster, like disaster recovery with things like Valero, or conformance testing or ingress with Sonabuoy and Contour. So how do we do kind of some of the day two stuff and automate that process as well? And then finally, user apps are layered on top of all of this. So that's really, kind of from tip to toe what comprises up a Kubernetes cluster. So we start with the components of Kubernetes. We've got our infrastructure. How do we bootstrap? Those components? So we have our container runtime, our kubelet, etcd, controller, scheduler, API server, kube proxy, our container network interface, and our DNS services all running, and we need to run and communicate and pass certificates to each other when we create our cluster. So how do we bootstrap all these pieces, and how do we ensure they can all communicate with each other? And that's where CubeADM comes into play. So CubeADM is a consistent cluster bootstrapping tool that we can use to deploy Kubernetes clusters on top of existing infrastructure. So CubeADM performs the actions necessary to create a minimally viable Kubernetes cluster. So there are CLI tools like CubeADM init, which creates the control plane or the master, and then things like CubeADM join, which will allow users to join worker nodes to an existing cluster, plug them into the master, ensure the master is aware of them, et cetera, et cetera. CubeADM cares only about bootstrapping the cluster, so we need to have existing infrastructure and networking in place. So it does not provision virtual machines or anything of that nature. It only cares about creating the cluster. It's used as the default bootstrap mechanism within Cluster API. So that's where Cluster API really comes into the mix. So how do we provision and automate the provisioning of the infrastructure that supports our cluster? So Cluster API is a declarative lifecycle management of our Kubernetes cluster. So, we really are talking about using Kubernetes primitives to deploy and manage Kubernetes clusters. So we can talk to our developers about using the tooling they're already familiar with in kubectl to automate the provisioning of infrastructure and the deployment of the resources on top of that infrastructure to create a Kubernetes cluster. So if we take a look at kind of the layers of the solution, this is really kind of what we're focused on with Cluster API. So at the bottom of the stack, you have some sort of API-driven infrastructure that has some sort of API gateway into it, whether it's a hyperscaler infrastructure as a service provider, vSphere, or in our example today, VMware Cloud on AWS. So some type of provider that exposes an API to create compute resources. So for the provisioning of those resources, Cluster API can reach out to that infrastructure provider's API and spin up virtual machines that will support the cluster. Then Cluster API handles deploying the bootstrap process via CubeADM to create that cluster and install the runtime of Kubernetes. And then finally, once we have that in existence as a cluster, our developers can deploy their add-ons and cloud integrations and utilize that cluster to deploy their workloads as they see fit. So Cluster API is an open source project, and it currently has 12 special interest group sponsored infrastructure provider implementations, AWS, Azure, VMware. Now, one of the big values of the Cluster API for vSphere provider is that for our customers and partners that are using VMC, if they've started hypothetically on-prem with vSphere, the constructs and the APIs are exactly the same in VMC, so they can easily migrate their code to deploy applications and deploy clusters on VMC by simply changing a couple of variables in an environment file. So that's really an important tenet in VMC in general, is being able to use the same constructs, specifically in this case the APIs, to extend your compute power into the public cloud with VMware Cloud on AWS. So there's also a ton of community participation outside of just VMware, obviously. So we have a couple of logos on the screen for some of the more prominent contributors to the Cluster API community, and VMware itself is a contributor to the community, and we are very active in the Cluster API community as well as the Kubernetes community in general as the third overall contributor to the code. So we're very invested in ensuring Kubernetes is successful, especially with respect to our enterprise customers. So from a high level, this is what it looks like for a user to provision a cluster via Cluster API. So our user has a YAML file that defines things such as the name of a cluster, the bootstrap configuration that we're going to use via CubeADM to create the cluster components and link them together, the number of control planes if we want a highly available cluster with multiple masters, as well as the number of workers that we want. So essentially the specs of a cluster. The user passes that YAML file with kubectl to what we call the management cluster. And the management cluster then communicates with the underlying infrastructure, so in our case vSphere, to provision virtual machines, instantiate them, bootstrap them, install the Kubernetes components, and then connect all those components together to have a fully functioning Kubernetes cluster from a couple of YAML files that we pass, just like we would with a pod or a deployment or a service to an existing Kubernetes workload cluster. So there are a couple of abstractions that are important to understand in the Cluster API world. So if we have our components of a Kubernetes resources, whether it's a pod or a replica set or a deployment, we have very similar constructs in the Cluster API world as well. So analogous to a pod is a machine. So this is exactly what you think it would be, a virtual machine. So we define the specs of a virtual machine, how big we want it to be, what part of the cluster we want it to be a part of, whether it's a worker or a master, et cetera, et cetera. Then we have a machine set, which is analogous to a replica set. So this allows our Cluster API management cluster to monitor our workload clusters, as we'll refer to them, to make sure that our machines, a part of the machine set, are up and available and functioning. And if a machine is in a problematic state, the Cluster API management cluster will simply destroy that machine, spin up a new machine to take its place, much like we would with a pod as part of a replica set and a deployment. And again, a machine deployment is layered over top of a replica set. This is our entryway into creating worker nodes that are managed by machine sets. And then we also have this idea of a cluster. So this contains kind of, this is a resource that is basically the container for our workload clusters. So it contains cluster-wide information like generic networking concepts, CIDR blocks to use for the private network, the name of the infrastructure provider, things of that nature. If we look at an example of a machine YAML file, this is where we talk about configurations that's specific to a machine. So spec has the the desired kubelet version, the name of the machine, et cetera, et cetera. We talked about bootstrap config. So we're referencing bootstrap configs in machines and machine sets, and machine deployments as well. So when the machine is spun up, it looks at the bootstrap config to understand, hey, how do I, how or what do I do to become part of or part of a Kubernetes cluster or become a master of a Kubernetes cluster. So that's where we use something like a bootstrap config to say, okay, this is how we use something like CubeADM init to bring a control plane into existence, or CubeADM join to join a set of machines into a cluster as workers. And this is just an example of a machine deployment. And here we define things like replicas. So just like in a deployment where we define the number of replicas we want for a pod, here in a machine deployment, we define the number of replicas that we want for our worker nodes or our nodes in our Kubernetes cluster. So we also define things like a template or an image to use, or a machine template to use for our machines, and we can edit these deployments to scale up or down our clusters, after the fact. So we've talked about management clusters and workload clusters, but what is exactly is comprised of a management cluster? And essentially, we create a management cluster. The cluster API tooling installs CRDs, or custom resource definitions, controllers, and then provider-specific information into the management cluster. So the management cluster can communicate with the underlying infrastructure to provision virtual machines. So provider-specific information are things like, in our case, the host name or IP of our VMware on AWS vCenter appliance, the user credentials, as well as things like the template to use, the resource pool to use, the network to use in our VMC environment. So then our management cluster can do things like create all of those resources we just talked about. It can create a machine, it can create a cluster, it can create a machine deployment, and then automate the creation of the clusters. Cluster API creates infrastructure and bootstraps the target clusters. So if we look at the diagram on our right, we have cluster A and cluster B definitions that include things like bootstrap config, control plane machines, and machine deployments. And that when the management cluster receives a YAML file that has all these specs, it uses its custom controllers and custom resource definition controllers to reach out to the infrastructure to create all these resources, bootstrap the cluster, et cetera, et cetera. In the next session, we're going to go through a detailed walkthrough of how this all works with the management cluster and the workload cluster. But before that, I want to take a little bit of time to talk about the quote-unquote pivot workflow. So essentially, when you instantiate a cluster API deployment, we need to create a management cluster, but as you may have noticed from all those YAML files, it's kind of complicated and there's a lot of code that goes on, and we have to create all these custom resource definitions in a management cluster. So that's why we use a tool like Cluster API and a bootstrap cluster to create kind of a template of a management cluster, and then we can then move that template into the management cluster. So we start with the bootstrap cluster. Usually we'll use Kind, Kubernetes, and Docker, which we'll talk about in the next session in detail. We install all those CRDs and controllers in the Kind cluster on our local workstation or our jump box. And then we essentially copy all of those CRDs and controllers and provider information over to a new cluster that we've created, which then becomes the management cluster. So the bootstrap cluster creates the machines that will serve as the management cluster control plane, and then migrates all of the cluster API stack over to the management cluster. And then After cluster API is confirmed, the management cluster is up and running, the bootstrap cluster or the kind cluster is deleted, and then users going forward will use kubectl to communicate with the management cluster to provision X amount of workload clusters going forward. So we only have to do this process, the pivot workflow, one time, and once we have our management cluster stood up, it is the management cluster going forward for deploying multiple workload clusters. So that concludes our session on Cluster API overview. In the next session, we're going to walk through specifically using Cluster API for vSphere to deploy Kubernetes clusters on our VMware Cloud on AWS environment.